Okay, this lesson's binomial radical expressions. When you finish this lesson, you'll be able to rationalize the denominator of something that looks like this, 6 plus root 15 over 4 minus root 15. In other words, we'll be able to get this radical out of here. Add or subtract if possible. Well, I've got the 5 times the cube root of x minus 3 times the cube root of x. Since these are like terms, I can go ahead and do that. It is possible. It's 2 cube root of x. The next one, I got 4 root 2 plus 5 root 3. These are not like terms, so it's not possible to simplify. Add or subtract. Give this a try. What'd you get? 5 root 7? Good. Give this one a try. Be careful, we have a 4th root here and a cube root there, even though these are fifths of 5. They're not the same, so it can't be simplified. Try this one. If you said 9 root xy, you're right. I have an xy type thing here. I have another xy type thing here, so I have like terms. I can go ahead and add them together. Let's simplify this one. In this example, we're going to simplify before adding or subtracting. 6 root 18 plus 4 root 8 minus 3 root 72. None of these are alike, but root 18 is the same as root 9 times root 2. Root 8 is the same as root 4 times root 2, which is 2 root 2. In fact, you see root 8 enough, you might as well just learn that it's 2 root 2. You get tired of writing it out in this form. And root 72 is the same as root 36 times root 2. The square root of 9 is 3. The square root of 36 is 6. So here I have 18 root 2, here I have 8 root 2, and here I have negative 18 root 2. The 18 root 2 and the negative 18 root 2 will just cancel each other out or add to 0, and I'm left with 8 root 2. So sometimes you need to simplify before adding or subtracting so that you can get like terms in order to add or subtract. Try this one. Go ahead and pause the video. When you're ready to check your answer with mine, press play. Alright, let's see. Root 50 is 25 times 2. 32 is 16 times 2. And 18 we just saw is 9 times 2. Root 25 is 5. Root 16 is 4. And root 9 is 3. 5 root 2 plus 12 root 2 minus 15 root 3. Well, it's 17 root 2, oh, excuse me, 15 root 2. 17 root 2 is minus 15 root 2 is just 2 root 2's. Here's another example. We're going to multiply. We're going to use a method that's probably familiar to most of you. We're going to FOIL. So FOIL is first. 3 times 2 is 6. Outside, 3 times 4 root 5 is 12 root 5. Inside, 2 root 5 times 2 is 4 root 5. And finally, lasts. 2 times 4 is 8. Root 5 times root 5 is 5. 8 times 5 is 40. That's the trickiest one. Let's look at that again. 2 times 4 is 8. Root 5 times root 5 is 5. And 8 times 5 is 40. We should have like terms in here to go ahead and combine because we started with root 5's in both places. So root 5 times 12 root 5's plus 4 root 5's is 16 root 5's. And the 6 and the 40 also combine to 46. That's it. You try one. Remember, though, that when you square a number, you're not just squaring everything inside. You actually multiply the thing by itself. So go ahead and multiply that out. Okay, this is what I would do. I would follow FOIL or double distribution, however you want to think of it. Root 2 times root 2 is 2. Root 2 times negative root 3 is negative root 6. Negative root 3 times root 2 is another negative root 6. Negative root 3 times negative root 3 is positive 3. Combining like terms, I get 5 minus 2 root 6. Pause anytime you need to look at things longer. Otherwise, we're moving on. You try one. Notice we're multiplying by conjugates here. I have 2 plus root 3 times 2 minus root 3. Anytime the only difference between the two binomials is a sign in the middle, a plus and a minus, one's positive, one's negative, we're multiplying conjugates. The cool thing about multiplying conjugates is they're in the form of difference of squares. a plus b times a minus b, which means that if I understand this and I recognize that I can take a shortcut instead of foiling all out, I just take the first thing and square it minus the second thing and square it, just like difference of squares formula that we learned earlier. 2 squared is 4, root 3 squared is 3, 4 minus 3 is 1, and we're done. You try one of those. Notice the conjugates. Hopefully you just took the first thing squared minus the second thing squared, which would give us 5 minus 2, or 3. Now we're going to actually rationalize binomial radicals here. So I want this radical out. And we just saw in the last 2 examples that if we multiply by conjugates, even though we're multiplying radicals, we don't have radicals when we get done. So let's multiply top and bottom of this fraction by the conjugate of the denominator, the 1 plus root 5. The denominator's easier. Let's do it first. It's just the first thing squared minus the second thing squared, 1 minus 5. The numerator, we have to go ahead and FOIL out or distribute out. We get this. Combining like terms and simplifying in the denominator, we get 8 plus 4 root 5 over negative 4. Divide everything in the top by negative 4. The result is negative 2 minus root 5. Now you try. Remember, this is the problem we said you'd be able to do at the start of the lesson. We said you'd be able to do when you got to the end. Let's go ahead and pause the video and give that a try. All right, let's go ahead and get the conjugate of 4 minus root 15, which would be 4 plus root 15. Multiply top and bottom by that. The bottom is easier, so let's do it first. It would be 4 squared minus root 15 squared, or 16 minus 15. That's nice. It's just going to be 1, so whatever we get on the top is going to be our answer. Let's go ahead and FOIL or distribute that out and simplify things up. We get 39 plus 10 root 15. Hopefully that's what you got too. That's our learning target for this lesson. I'll see you in class.